Hello everyone, welcome back to another video of our multithreading in Java series. In this video, we are going to solve one of the most classic and most asked concurrency problem in Java interviews, the producer-consumer problem. Now what makes this video different from every other producer-consumer video on YouTube is, we are not just going to solve it in one way, we are going to solve it using different ways, starting from the most basic and broken version all the way to the production ready solution. Now in the end, we will also handle a small variation where multiple producers and multiple consumers are running simultaneously. So if you are preparing for a Java interview at any product based company, this video will cover mostly everything that can be possibly asked to you about producer consumer. Now before we write a single line of code, let us understand the problem completely. Imagine you have a conveyor belt in a factory. On one side, you have a producer. The producer's job is simple. Produce items and put them on the conveyor belt. On the other side, you have consumer. The consumer's job is also simple. Pick items from the conveyor belt and process them. And in the middle, you have a buffer. Think of it as a conveyor belt. It has a fixed capacity. Let's say it can hold 5 items at a time. Now the problem is, both producer and consumer are running on separate threads at the same time, and they both are accessing this shared buffer. Now this is where things get complicated. So let's see the edge cases that we need to handle. The first edge case is buffer full scenario. What happens when the buffer is completely full and the producer tries to add one more item inside the buffer? Now if we don't handle this situation, the producer will try to add to a full buffer. Now this will either throw an exception or override the existing data. So handling this edge case is very important. Now the second edge case is buffer empty. What happens when the buffer is completely empty and the consumer tries to take an item from the buffer? If we don't handle this scenario, the consumer will try to read from an empty buffer. Now this will return null or throw an exception, correct? Now the third condition which we need to handle is the race condition. What happens when producer and consumer access the buffer at exactly same time? Producer is adding an item and consumer is removing an item, both at the same nanosecond. Now this can lead to data corruption, inconsistent state, and bugs that only appear under heavy load and are nearly impossible to reproduce. So this is the most important condition we need to handle, the simultaneous access condition, correct? Now the fourth edge case which we need to handle is the busy waiting problem. Now what is busy waiting problem? When your buffer is full and producer needs to check when does the buffer becomes empty so it can put an item inside the buffer. To check that, a naive solution would be, when the buffer is full, keep looping and checking until the space is available, right? Now this problem is called busy waiting. This basically wastes CPU cycle completely. The thread is doing nothing useful but repeatedly consuming CPU resources and checking if the buffer is empty or not, correct? Now instead of that, the thread should actually sleep and wake up only when this condition is met. It should not check repeatedly. So this is also one of the most important things that we need to handle to optimize our CPU cycles, right? Now the fifth edge case which we need to handle is the spurious wake up. This is something most developers don't know. What happens? A thread can actually wake up spuriously, meaning a thread can wake up from wait state even without being notified. Now, this is a known behavior of the JVM and operating system, right? So if a thread is woken up without being notified and you are using if statement to check whether the buffer is full or not, what will happen? When your thread wakes up spuriously, it skips this check, correct? It has woken up. It will proceed further and try to execute further conditions like producing an item and putting it inside the buffer even though the buffer is actually full. So that will be complete disaster, right? So to avoid this, what we do is we use while statement instead of if. Now suppose your thread is waiting on full buffer and JVM wakes your thread spuriously. Even though JVM wakes it, it again goes, your thread goes, and since it is in while loop, it will check whether the buffer is full or not. If the buffer is full, it will go in waiting state again, correct? It will not go ahead and execute other statements, correct? So this is how you solve spurious wake up, by using while with wait instead of using if with wait. This is a no exception, no brainer thing. Always you should use while whenever you want to wait on a thread, correct? I will link a YouTube short also which will explain you a bit about spurious wake up. Now let's go ahead and code this problem in our IDE. Alright, let's write our first version, the most basic approach using wait and notify. So let's start with the buffer class. Now this is our shared resources, which is the conveyor belt our buffer class have. Our buffer class will have a queue where the producer will produce item and consumer will consume from that, right? So let's go ahead and create that private. Right, after this we'll have a variable named capacity. This will be the maximum capacity that our queue can have. And now let's create our constructor. Okay, both, right? Let's remove this from here and our buffer will be equals to new, let's create a linked list, right? Done. Now what else our buffer will have? Our buffer will have two functions, one to add inside the buffer and another one to consume from the buffer. So two functions will be public void add inside the buffer and another one will be consume from the buffer. Now what will be the code inside add inside the buffer? So add inside buffer, this function will be called by the producer to add an item inside the buffer. So what will our producer check? So our producer will first of all check whether the buffer is full or not, right? While buffer dot size is equals to capacity. If our buffer is full, then what we have to do? We have to go ahead and wait, right? So our producer thread will go ahead and wait if the buffer is full. And let's also write system.out.println can't produce going to wait, right? This is the message that will print on the console. Now if the buffer is not full, then it will go ahead and produce an item and put it inside the buffer. So let's go ahead and produce an item, buffer.add, but what will be the item number? So for that, let's go ahead and create another variable, total equals to 0, right? First we'll increment this total plus plus buffer.add item, what number is added, total, right? So item 1 is added, and then we'll go ahead and print system.out.produced item itna, right? So we have produced an item, we went ahead and printed it, and then we did notify all. So all the consumers which are waiting on the buffer, we have gone ahead and notified all those threads that now an item has been produced, you can come and consume from the buffer, right? Now let's write our consume from buffer method. What consume from buffer method will do? This will be used by our consumer threads, and our consumer thread will first go ahead and check whether the buffer is empty or not. If the buffer is empty, then our consumer will wait, right? So while buffer is empty, then we'll go ahead and wait, right? And we'll also print can't consume going to wait, right? And if our buffer is not empty, then we will go ahead and consume from the buffer. So we'll write system.out.println consuming from the buffer. What we have done, buffer dot, we can also use poll, correct? So it will go ahead and remove the item from the buffer and consumed whatever that item number is there, that will be printed, and then we will write notify all. So all the threads which are now waiting for the buffer to become empty, for example the producer threads, those threads will be notified, and those producers will go ahead and try to insert an item inside the buffer, right? So this will be used by producer, and this method will be used by consumer. But one of the most important thing which is not handled here is race condition, right? So we have to make sure that this buffer is accessed by either the producer or consumer. Both should not be able to use the buffer simultaneously, right? So we'll go ahead and wrap this whole logic inside our synchronized block, right? Same will be here, synchronized this, and we have kept a common monitor object, this object. So only one of producer and consumers can enter inside this block and access the buffer at a single point of time, right? Now let's go ahead and write our main class. In our main class, what we'll do, initialize our buffer with a capacity. Let's give our buffer a capacity of 5, right? And after that, we have to create 2 threads, one for producer and one for consumer, right? Equals to new. What will be the logic inside this? Let's say we want to produce 10 items, right? So if we want to produce 10 items, we'll run this loop for 10 times and we'll go ahead and do buffer dot add inside the buffer. Right, let's go ahead and create our consumer thread. Equals new thread. Here what we'll do, we'll go ahead and consume the 10 items that was produced by the producer, right? We'll write buffer dot consume from buffer, right? Producer dot start and consumer dot start, right? Now one more thing that I want to do is the rate at which the items are produced inside the buffer, that I want to control. So I'll go ahead and write thread dot sleep 1000 milliseconds, right? And in case of consumer, I will write thread dot sleep for 2 seconds, right? Right. So what is happening here? Our producer thread is waiting for 1 second after producing an item inside the buffer, and our consumer thread is waiting for 2 seconds after consuming an item from the buffer. So the rate at which producer is producing the item is different and faster than the rate at which consumer is consuming the items from the buffer. Since the producer's rate is more than the consumer's rate of consuming, so there will be a time when the buffer will be full and our program will go ahead and print can't produce more items and now I am going to wait, right? So that's it for our main class. Let's go ahead and run this and see whether 10 items are produced and 10 items are consumed or not, right? Produced 1, consumed 1, produced 2, 3. See, 1 item is consumed but 2 items is produced. So the rate at which the production is done, that is faster than the consumption, correct? Now 10 items have been produced, 6th item is consumed, 7th, 8th, 9th and 10th item is consumed, and after that our program stops, correct? So this works perfectly fine. So this was the most basic version where we used wait and notify. We had only one producer and one consumer and we had one buffer, right? Now what is the problem here? If there are multiple producers and multiple consumers, when you go ahead and write notify all the threads, whether it is producer and consumers, they go ahead and wake up. Instead of that, what we should do, when the producer thread calls notify all, only the consumer, multiple consumer threads should go ahead and wake up. This problem will not be observed here because there is only one producer and one consumer. But in case of multiple producer consumer, this notify all will wake up all the consumers as well as producers also, right? Which we don't want. So this is one limitation in this version. Now the same version can be written using ReentrantLock and Condition, and the main thread will remain exactly same. The only difference will be in our buffer class. Buffer class also, all the logic will be same. Instead of using synchronize this, we will use ReentrantLock as our monitor object. So I have already implemented the same thing. Let's go ahead and correlate these both classes, right? So this is our buffer class, which is using ReentrantLock and Condition. So what we have here, we have a ReentrantLock and we have two conditions. One condition is full and one condition is empty. Now let's see how we have used it. This is exactly same. Now this is our add inside buffer function. Instead of synchronized, we have used lock.lock. So producer will go ahead and acquire the lock, correct? After acquiring the lock, producer will go ahead and check whether the buffer is full or not. If the buffer is full, then it will go ahead and wait on full condition queue, correct? That's why we have written full.await. Instead of just wait, we have to use the full condition. This is exactly same. Total plus plus. A new item is produced inside the buffer, that is printed, and then when an item is produced, we will go ahead and do empty.signal. Now this is very important. We have not just blindly used notify all, we have used empty.signal. And which all threads will wait on empty condition? Let's go ahead and check our consume from buffer method. In our consume from buffer method, this will be used by all our consumer threads. Consumer threads will first go ahead and acquire the lock. After that, we'll check whether the buffer is empty or not. If the buffer is empty, then we will wait on the empty condition. So who is waiting on the empty condition? Consumers are waiting on the empty condition. And who are waiting on the full condition? Producers are waiting on the full condition, right? So we have done empty.await. Right? We'll wait until the buffer is non-empty. When the buffer is not empty, we will go ahead and consume one item from the buffer and we will do full.signal. Now see, we have done empty.signal. We can also do signalAll here. Even if we write signalAll, there is no problem. The main point to notice here is the producer is signaling only the consumer threads to wake up, right? Unlike here, in our wait notify version, we wrote notify all, where all the threads, irrespective of whether it was producer or consumer, those were waken up. But here, only the threads which are waiting on empty condition, who are the consumers, will be notified, right? And once the consumer consumes an item from the buffer, only the threads which are waiting on full condition queue, which are our producers, will be notified, right? So this is one improvement that we have done from our basic wait notify version. Our main thread will exactly be the same. We have used the same rate limiting for producers and consumers. The only difference is this buffer class, right? Now let's go ahead and run this and see whether we have the same output or not, right? Produced 1, consumed item 1, produced 2, consumed item 2. Again, the rate at which items are produced is more than the rate at which items is consumed, right? And how many items we have produced here? Okay, so we are producing 20 items here, right? And 20 items we are consuming as well. So let's wait a little more time. Produced 18, 19, 20, right? 16th item, 17th item is consumed, 18th, 19th, 20th, and done. That's it, right? So our program is working as expected. So this was our second version. Now in production, we don't use this wait notify version or ReentrantLock or condition version. Instead, we use a built-in class which is BlockingQueue, which inherently handles all these locking mechanism, blocking of producer's thread, blocking of consumer's thread, simultaneous access, race conditions. Everything is handled using our BlockingQueue class. BlockingQueue version is the simplest version of this all. If I show you the BlockingQueue version, this is the code of BlockingQueue. So our main thread will look exactly the same. 10 items are produced, 10 items are consumed, right? But the buffer, this is how it will change. We have a simple queue called BlockingQueue. We have initialized it here, right? And you don't need to acquire the lock or do anything. You just have to increment the counter, put that item inside the buffer, that's it. And in consume from buffer, you have to take that item from the buffer and then print ahead. That's it. By default, whenever the buffer is empty, then the consumer will go in wait state. And by default, when the buffer is full, the producer will go inside the wait state. This is handled in BlockingQueue itself, right? So let's go ahead and run this and see, consumed 1, produced 2. Now it might seem like consumption has happened before the item is produced, but that is not the case. Since both the thread are running parallel, either the consumer or producer, anyone can print it before, right? If we go ahead and run, we might expect a different order. In last, our output should be 10 items should be consumed and 10 items should be produced, right? Right? This time produced item 1 is printed first, and after that the consumed is printed. Correct? Now there is one very interesting variation that is asked in interviews, which is what happens when there are multiple producer and consumer? How does the code change? To be honest, nothing changes inside the code. This buffer class remains exactly the same. Right? The only change we have to do is inside our main class, we have to create multiple producers and multiple consumers. This is exactly the same. This is exactly the same as we used for single producer consumer. But in our main class, what we have done, we went ahead and created 2 producer threads and 2 consumer threads. Correct? So now the production will happen fastly and consumption will also happen fastly. We have run the internal loop for 5 times. So in total 5 into 2, 10 items will be produced, 5 from producer 1 and 5 from producer 2. So let's go ahead and run it. If I run it, I see the production rate has increased because there are multiple producers, and similarly the consumer rate has also increased. Correct? So within, I think, 5 seconds everything is done, right? So this is how multiple producer consumer program is implemented. So all in all, if we see, you only need to understand one version, which is the wait notify version, very nicely. And once you understand this, you only have to change the monitor object and it becomes ReentrantLock and Condition implementation. Correct? And post that, the blocking queue is the simplest one. You don't have to use any lock and anything. You just have to replace the queue using buffer using blocking queue, and then go ahead and put the item inside the buffer and consume from the buffer. And for multiple producer and consumers, there is no change inside the buffer class. You just have to go ahead and create multiple producers and multiple consumers. So you can go ahead and play with more number of producers, where the rate of production is less than the rate of consumption, right? So I hope you understand this producer consumer problem well. Make sure you understand all the edge cases that I have explained in the blackboard. That's it, guys. That's it for this video. Until the next video, stay safe, stay healthy. Bye bye.